Hi all, good morning or good evening, depending on where you are located. Thank you for joining our Power BI webinar, and my name is Deepak Shankar. I'm a community manager within the Microsoft Business Application Group. And today we have Marcus, an MVP with us, who will walk through the new Power BI features and the self-service AI in Power BI Desktop. Hey Marcus, welcome to our webinars and it's all yours now.
Thank you, Deepak. Hi, everybody. Really happy that you joined my webinar today. So let's go into the title. It's about AI, artificial intelligence in Power BI Desktop. So everything I will show you will be available in Power BI Desktop, the free tool. So there's no fees attached. One slight exception is at the very end, you will see something about cognitive services and machine learning services. There you need a subscription, but also there's subscriptions available for free. So if you just want to play around, everything is for free here. So for the agenda, I chose a lot of stuff. So the agenda is full packed with Q&A, quick insights, what if parameter, analytic line, R integration, cognitive services, Azure Machine Learning. And the definition of AI for this is not a very scientific definition, but what I think AI is everything which helps me from the tool. So everything Power BI can make my work easier. This is considered as AI here. So we will see some automagical stuff. So where Power BI is transforming stuff for you, discovering stuff for you with just a few clicks on the graphical user interface. And towards the end, we also will see machine learning algorithms in place. Some of them, again, like in cognitive services, are automatically available, so we don't have to tune anything. But we also see more advanced stuff in scripts like in DAX, in M, and in R code. So I hope this session will cover or have something for everybody of you, no matter which level in Power BI you are currently at. And from that, we will go to the demo, and we will not do the demo until the very end of this session. So if you have any questions, please let Deepak know via the chat window, so he can interrupt me and can clarify any, answer any questions you might have. Other than that, let's go to the demo. So this is Power BI Desktop, and I paired it with my AdventureWorks thing here. So I've AdventureWorks loaded into the model. And the first demo is like, wouldn't it be nice if we could just double click on the pane and then start asking a question? So for example, sales amount. And Power BI is capable of understanding English text. As we can see here, the text is underlined in a red and a blue line. And this means it has discovered, or it thinks it knows what I'm talking about, and it showed me the 80 million of sales amount all in the whole of my model. So Power BI understands what I'm asking in English, and you can have this like by category. And if I enter category, it's suggesting that's the product categories, and this is really nice. I want to keep this, so I move this here, and we can use this. Here's the red line. Here's the red line. And there's also more here. So we can also ask for a question like sales amount by promotion. Promotion are my promotions we are doing, and we can transform this. So as long as this text icon, this text box is up there, we can change the question, and they can transform the Q&A into a real visual. So this is nothing else, does not distinguish itself from any other visual I would build through clicking on the fields or from selecting a visualization. And what we can do here, we can prepare, of course. So maybe I'm not interested in the no discounts because I am only interested in the promotions. So we can change this, and we can say exclude. This is a real visualization. Another thing is if we ask for sales amount by country. I think it's territory, something like that. I'm not knowing my my own demo well enough. Obviously, territory, group, or region. Then it should discover that it's like regional data, and it comes up with a map that automatically suggests what Power BI I think is a good visualization for it. And I totally agree. If it's territory information, this could be put on a map, or if it's categorical data, it should be on a bar chart. If I'm not satisfied with that, we can also change this. So I can write as bar chart, and then we get a bar chart for the regions as well. And of course, if it asks for like sales amount by date, it knows that we have continuous data, not the predicted date. I chose the wrong one. Want to have the order date here. It knows that it's continuous data, and it suggests automatically the line chart. So this is really, really cool. And when I first saw the people demoing the Q&A feature, I thought, yeah, this is cool for demos, but who would use that? And I discover myself that I'm really, really often use this, because double clicking the pane and then entering the fields and categories I'm looking for is much, much faster for me than finding the stuff in the fields and visualization pane. So we can continue with the sales amount by date. And what we're going to do here is I transform it here, and then we'll use half of the space. And when we take a look on this sales amount by date, we can see that there's like a peak here in January 1st. So this is where we hit the 4.2 million of sales amount. And again, wouldn't it be nice if Power BI could tell me what's special with this date, so we can find out why there's the peak there, so we can learn from that. And exactly that's what we can do. We can right click here, and then we have to analyze, explain the increase functionality. So if I zoom in here, so right click, analyze, explain the increase. And if we click this, then Power BI starts thinking. It's explaining here, here's the analysis of the 58% increase in sales amount between December 1st and January 1st. And then it's coming up with different things. For example, it came up with that the increase in sales, so we have different things here. You can scroll down there, and what it thinks the most important stuff is like on the top. And what we see here is it's suggesting the increase was because the gender of our employees, so the male salesperson, sold more than the females. This can be interesting or not, depending on what is the how many male and female salesperson we have at all. So maybe this is not so interesting, but for example, we can change it here. We can change this to a 100% column chart. And then we can see that in December, actually, the female salesperson had almost 1.4 million of sales, which is more than half, 52%, while the male only had 47%. And this changed to December, so the males overtook the majority of the sales. This can be interesting or not. Again, you can then give thumbs up or thumbs down to motivate Power BI coming up with insights, more insights like that. And you can even press the plus sign here. So if you press the plus sign here, the visualization is taking over, so we can easily share this insight we just got from the tool with all the others by adding this to our reports. And again, this is a normal visualization. There's no difference. So for example, we can change the colors. I'm a more conservative person, so maybe have the males in blue and the females in red. And to emphasize that the important message of this column chart is that the majority changed from one month to the other, we can add a constant line at 0.5. So everybody sees that the majority, 50% was here, and the majority was like for the females, and now changed to the males here. The next thing is getting a little bit more interaction. So what I want to do here is the following. I want to try out or play around what's happening if we would decrease the prices, if we would give more discounts on our prices. So we decreases the prices. And what we can do here is through modeling, we have the new parameter, what if? And I can give it a name. So this would be the new discount, a decimal number going from 0 to 1 in 1.0 increments, and we want the tool to add a slicer to the page. So we get the slicer and it adding a table, generate a table for that. And by giving discounts on the prices, probably the sales amount will increase, but there's no direct connection. There's this idea of elasticity of prices. So we add another parameter for the new elasticity. Again, a decimal number from 0 to 5, and again in 1.0 steps. Fun enough, even if you select add slicer, no slicer is added. Okay, this is new, something went wrong. Okay, let's see what's happening here, what it did create or what it did not create. Yeah, it created the new elasticity, but for some reason the slicer is not created. This also happened in previous demos to me, but no worries, we just can add it. We just select this new elasticity and add a slicer for that. So we have the slicer on our own. And then we can, of course, select discounts. We can also change the discounts to be a percentage value. Maybe let's do that, modeling, and let's make this a percentage. And when we change this here, then we should see this is a percentage up there, and the elasticity is not a percentage, but we could put it to 1 now. So now the question is, how does this change our sales? So what I'm adding here is we have under the measures, I have my sales amount. I want to add the sales amount as multi-cut row. Make this a little bit smaller. And then we add new measures. So we want to have what's the price when we have the new thing here. So we can go in here, and I have the DAX here. So I do not need to type it. So add a new measure here, new measure. And this new measure is the new price. We can increase this in size. Everybody can read this, hopefully. So we have this new unit price, which is the average over the selected old unit prices times 1 minus the discount amount. So if the discount amount is 24%, which is 0.24, the unit price is multiplied by 1 minus 0.24, which is, let me calculate, 7.3. So we only, the price is now only 76 percentage. I should calculate this with easier numbers. So if the number is like 10%, that's what I can in my head, then the new discount value would be 0.1, and 1 minus 0.1 is 0.9. So we multiply the price by 0.9, so we get this discount of 10%. That's what I'm creating here in this measure, and I add this measure to my multi-cut row. The next thing, and as we can see here, now I add first the measures, and then we can see the things here. So I add a new measure here, and this second new measure is the sales amount. And for the sales amount, it's not directly connected to the new discount value, so the percentage, but it's all also depending on the elasticity. So elasticity of 1 tells us if we decrease the price by 10%, then the quantity will go up by 10%. So because we have this 1 plus 0.1 times 1 stays the same, so it's like 1 multiplied, the quantity is multiplied by 1.1. If the elasticity has 2, it means for every percentage we are decreasing the prices, the amount is going up 2 percentage. 2 percentages. That's what you get from the new quantity. Again, add this measure, and then I add the measure to my multi-cut row. Then we want to see how this affects the sales amount. So the new sales amount, new measure here. The new sales amount is like the new price, the new quantity times the new unit price. Those two values we just recalculated previously. We add this as well. And then for convenience reason, I want to see what's the difference. So if we do this, will the sales go up or down compared to the old prices, to the old sales amount? So I calculate the difference between the new sales amount and the old sales amount. We add this as well. And then we can play around. So we can, for example, increase the discount amount to 16% with an elasticity of 1. This would not be a good idea because we would lose 2 million. But if the elasticity goes up, then we can see that the quantity is going up. Let's make this a little bit smaller. So when I change the discount, we can see that if I increase the discount, the unit price goes down. If I increase the discount, we can see that the quantity is going up. So 274, 299 now. And if I increase the elasticity, the unit price will be the same, but the quantity is going up. And that's how we can influence this. What is the elasticity of your prices of your goods? You have to find out. This is an economic concept, and one way would be to ask your customers, your potential customers, how much would you buy for this price? How much would you buy for this price? Of course, this concept has its limitation. So even if a liter of milk or a gallon of milk is only costing 1 cent, you would not drink, I don't know, 20 liters or 10 gallons a day. So there's certain limitations. And for like high price goods, there's also a limitation. If luxury a good would, like, I don't know, Rolls-Royce would decrease the prices to a really small amount, then of course ordinary people like us could buy a Rolls-Royce, a car like this, but they would lose other customers because they buy a Rolls-Royce because it's exclusive and nobody else can afford it. So of course there's a limitation in the concept. Then we can see, like, is there, like, where's the ideal point? And what we can do here is I can create a line chart and putting the new discount amount on it. The new discount here. And I also put on the difference, the new sales amount difference on the values. And what we can see here is like a really, really annoying line chart, because this line chart only has one data point. So it's not a line chart, it's just one point here at 30%, because this guy here, the 30%, is filtering everything on the screen and also filtering the line chart. So how can we avoid this, that we can get see all the percentages and it's not filtering? We can go to format and add it into actions, and I can tell this new discount amount to not filter the line chart. Now we get the full line chart, and we see like the curve, and somewhere there would be the sweet spot. And of course we can add again a new analytic line at the max position. I add a line here, and we also add the data label. Unfortunately, we cannot change the size of the data label. The data label usually is really, really tiny. So it tells us the sweet spot, what we would have at this elasticity at 1.61. The sweet spot would be to decrease the prices, so we could at the end have 4.6 million sales more than before. But where is this part, this discount point? You can try to find it, like with the hover help, to find the point there. Probability, it's a little bit lower. Yeah, you can play around then, or we can again facilitate DAX for that. So I have 2 DAX measures here. I first create the measures and then I discuss what's going there, what's happening in these DAX measures. So first one is the new max sales amount difference. What this is doing is it's going through this table we created with the what if parameter. What if parameter created the table for us, having values from 0 to 1 in steps by 0.01, like the thing I filled out previously. And it's going over all those values and trying out on calculating the new sales amount difference, this guy there. And then for all those values, it will be 100 values from 0 to 1. It will come back with the maximum thing. So max x is an iterator, and it's going through all the values and returning the maximum. So what we get returned from this thing is the 4.6 million. Let's see if this is true. I'm clicking there, and then we create again a Matero card, and I'm adding Matero card here. And I'm adding the new sales max thing here, the 4.6 million. It's exactly the number. And the next step would be to find the discount percent where the calculation goes exactly to 4.6 million. So we have the maximum sales amount. So we find out what's the discount for that. And again, we can do this with DAX, a little bit longer thing here. I will again create it and then we'll discuss it here on the screen. What this thing is here, it's working with variables. If you're not familiar with variables, they're called variables, but basically it's constant. So we are assigning a value to it that this value cannot change throughout the whole calculation. So I'm storing the new max sales amount, new different. That's the thing we just calculated one step before into this variable. And then I'm using the min-x to filter out all the discounts where the new sales amount difference is the maximal thing here. So we're finding the point, the discount amount, where this is exactly the value, and we're returning the discount, so the percentage for that. And if there is a point where we have more than one ideal point, it's very unlikely, but it could happen. So in this case, I'm returning the smaller of those discounts percentages. It could also be a max, or you could find another way of equaling out the two values maybe. So returning the average of those two, for example. So if we do this, then we get the full answer for our calculation. We can add the new best discount amount here. And again, it's blank because this little guy here, the new discount amount, is filtering the other one. So again, we want to avoid the interactions here. I think it's this one. Sometimes a little bit tricky to find the right one. Is it this one? Or is it this one? It's not this one. It should be this one. And I made something. Maybe I have to refresh it. Sometimes that's the reason. Okay, I've got my fallback here. So here it's showing the right thing. If we go again to 1.6, I think it was previously, then we have this sales amount, and the new discount amount would be the 19%. And if we try to get this here, the 19%, then we will see that exactly the we reach this 4.5, which is the maximum there. So next thing, what we can do here is, for example, we can add a table having the date there, and then having different measures like the discount and the freight and the order quantity and the standard cost and the sales and the tax amount, the product costs, and so on. And if you try to take a look on this table, it's really hard to see if is there a correlation between those values. So the discount was here 0, the freight was 12,000, then the discount amount went up, the freight also went up, but then the discount amount only went back to a third, but the freight went up again. So the thing is the correlation between items there? Can we learn from the data? And just looking at the data, all those columns, it's really hard. But what we can do here is I can take this table, copy it down there, and then we make a different visualization for that. One way would be to use like the correlation plot visualization. If we use that, it's calculating the correlations for us, and we can of course zoom this out so we can see it easier, a little bit better. Let's zoom in here. So what we see here is that like blue dots. Some of them are darker, some of them are really light, and we have the legend here. So if it's blue, there's a positive correlation between two items. If it's more the red, it's a negative correlation. So we only have positive correlations here. And the darker, or the hard to tell, is it the hue, or what's the English term for that? So the more blue it is, the higher the correlation would be. And of course, the correlation between the discount amount and the discount amount is 1. That's a blue dot in here. Between the discount amount and the freight, you have seen there's slight correlation, but it's really a weak correlation, something like there. So we can use this, for example, to find out the correlation. We can also duplicate the thing here. We can build the very same thing with R, which makes a little bit of more flexibility, if we can do that. So I want to copy and paste this here. Does it work? Copy and paste. Does not really work. Can I copy and paste the other one? Yeah, not copied. Probably I copied the other one 4 times now. So I can change this to an R visualization, R script visualization, which is a standard visualization. The core-plot visualization is a custom visualization, which I downloaded from the marketplace. So there's this ... here, import a custom visualization where we either need the binaries of the visualization on your machine, or you can download it from a marketplace. The R visualization is coming out of the box. What we can do here is that I change the visualization, and then we get this little R script editor here, which tells me that the following code creates a data frame. So Power BI is creating a data frame for me. If you're not familiar with the data frame in R, basically that's a table. There is also the data type table in R available. But if you use the relational data, pivot tables and the like, then data frame is your friend. And in this comment, so everything which has this hash sign at the beginning is commented out. So it's only a comment telling me that this data frame consists of all the variables I put in here under the values. So we have the date, discount amount, and so on and so forth. And Power BI automatically always only returns the unique data set. So there will be distinct values. And then at the very end, pass or type your code here. And that's what we are going to do here. So to get the core plot, there's this library core plot available. So in R we have, I looked it up back in October, November, over 15,000 packages, libraries available, which is really interesting, but also overwhelming if you're starting with R, because all those libraries have different things implemented. And so that's a really good thing that this is a quite active community, but it also makes it hard to start. So start with things you're familiar with, or start with things you find in nice books or Stack Overflow, and start from there. That would be the best way, I would say. And we can then have the core plot. So what I'm doing here in the data set is that I'm removing the first column, because the first column is the date, and I'm not interested in any correlation between the date and the other things, only between the other things. I only have the date here to avoid that Power BI only returns one row with the sum of discount amount and the sum of freight. I wanted to have several values per day, and that's why I inserted the date here, but I'm not interested in correlation here. And then we have the core plot functionality, and I want to calculate the correlation of the data set. And if I'm lucky, we should see, I'm not lucky, I have a typo in here, object data set, date set. Okay, I have a data set, where is it here? It's not date set. I was talking about the date column, and then I typed in the data set. So we have the very same thing here. So now you're asking yourself, why use the more complicated script here? Because the script is more flexible. So if you want, you could also come up with the core plot mixed functionality, which I could not replicate with the custom visual. And this is changing the script a little bit. And again, I have a typo here, core plot mixed correlation with double R, I guess. Yes, here it is. And then we zoom this out. So this is changing the script a little bit by showing us, can I zoom in here? By not using the full space for the dots, but only the upper triangle for the dots and the lower triangle for the actual numbers. So this light blue thing showing the correlation between discount amount and freight is here expressed in the same color and a smaller font like the one, 0.2. So that's what I was guessing here, that like it's up there. So R could give you more flexibility if you want to play around with that. The next thing I want to show is, again, have the date and have the sales amount available. Sales amount. You'll see this several times. That's my favorite thing. And we can also, again, make a line chart out of that. And when we take a look on that, I have the impression that there's like an upward trend. I mean, this is really volatile, so sales is going up and down over the time. But for me, it looks like there's an upward trend. And can we somehow prove that there's really an upward trend? One easy way would, again, our friend here in the analytic line. For the line chart, we have several things. Not only there, we have seen the max and we have seen the constant line previously, but here we also have the trend line. So I can add a trend line and this show me, yes, Marcus, you're right. There's an upwards trend over those years, over the sales. Again, we can use this, but it's not very flexible. So this thing is not even telling us how this trend line is calculated. I know it because I tried it out. This is a simple regression line, but it's not telling us that, and we cannot change the formula or the parameter for this regression line anyhow. What we can do instead is we can calculate the values on our own or from the internet, and that's what I did here. Where's the correlation? Here we go. This is the sales amount linear. I will copy and paste this. I will not type this in, and I will first show you how this is looking, and then we will I will walk you through the whole script, this DAX script here. So again, new measure, and I copy and paste this here. And I did not invent this on my own, but I took this from Daniel Maslik. He blogs here, and on his blog you also find insights, how he came up with this formula and what's the part. The most important thing I will show you during this webinar. So let's calculate this and then add this new sales amount linear to our line chart. So where is it? The new sales linear, and then we add this to our line chart. What's happening here? I want to add this under the values. Yes. So what's happening now is we can see, yes, the formula is obviously the same because the line is the very same. The only thing which happened here is that this DAX formula is not only calculating it for all the time or the time spectrum where are the existing values, but it's calculating for all the dates available in my date dimension. That's because I wrote the DAX script like that. But now we have to prove this is working, it is the same, and we can get rid of the DAX trend line there. So let's take a look on the DAX. So the first thing is, again, we have variables, we have the known thing, so that's the actual values. And what are the actual values? On the x-axis, we have the date. That's what we also have in the line chart. And on the y-axis, we have the sales amount. And that's the known data. This is used to calculate now everything else. And at the very end, we see the formula, the typical formula for a simple linear regression. We have the intercept, where the line is crossing the ordinate, the y-axis, and then for every value on the x-axis, our dates, we have a slope. So this is like going, if the positive slope is positive, for every day we get more sales. This could also be negative, then the slope would be negative, then for every day the sales would go down if we have a negative trend. The question is now, where is intercept and slope calculated? It's up there. So for the intercept, for example, and this is no secret, this is the formula for the linear regression line. You take the average of all the y values and subtract the slope times the average of all the x values. Average of all the y values is again here. Average of y is the is the average x. That's the formula, not the name of the value. So average x is it's going through all the known values and calculating the y value and then averaging it. So again, we have this iterator function we have already seen, and that's the average for the y. The slope is slightly more complicated. It's like a divide by, again, values which are calculated up there. So the number of the items we have times the sum of x multiplied by y minus the sum of x multiplied by the sum of y, and so on and so forth. So this is the known formula for a simple regression line, and Daniel took the effort and wrote this down in DAX. So with that known, we can now change, of course, the formula. So for example, if I do not want to have the trend line over the whole period, but only from 2013 on, because it's the most current data I have in my adventure example here. So if I change this and add a filter to our trend line, then we only get values which are greater and equal than the 1st January of 2013. So let's try how this looks like. I changed the DAX formula, I close the thing here, now it's starting only there. If it's only starting there, maybe we can only calculate it from 2013. So we don't get it calculated throughout the whole thing. And of course we can do this as well, because we can go to the formula again and add a filter up there. So we do want also for the known thing, not everything, but the all selected only for dates greater equal than 2013 January 1st. That's what we see here. And of course we can do this. The negative thing is, unfortunately, in 2013 we have a negative trend line, but don't shoot the messenger. That's what the data says. So with facilitating, for example, DAX, we're more flexible than having only the trend line available. We can also calculate stuff like that, again, via R script. So again, take the date here, and then take the sales amount. You see, with Q&A it's much faster. Just want to show you this is also possible without Q&A. And I use R for any calculation here. So now we can enter an R script down there. And this is hiding here, regression, here it starts, and it's going up there. You can, if you want, remove all the comments. So this is not necessary to have all the comments there. And then let's run the script so we can see what's happening in there, and then I will discuss the script here. So the blue lines, the green dots and the green line we are seeing here is again this very same sales amount we've seen previously. The visualization is a little bit different because I'm not using the line chart visualization from here, but an R visualization, which is then utilizing the ggplot2 package, which we'll see in a minute. And we have the trend line again here. So the information is basically the same like we've seen here. The green line is the actual value, the blue is the trend line calculated here in the R script. So how is this done? The script, I think reading the script is not that complicated. So I get again a data set from Power BI. I'm renaming the data set. So I'm moving everything over to another data set with a different name. I did this because I already had a script and I didn't want to change anything in the script. So I changed the name of the data set. So I'm copying stuff there. Then I'm renaming the column names. So in Power BI, they're called date and sales blank amount. I don't want to have this. So I'm renaming the stuff. I use the function call names, which is returning the column names of the data frame, which is date and sales amount. And then assigning, this is the left assignment thing here, the order date and the sales amount there. So from now on, the columns are not date, but order date, and not sales amount, but sales without a blank amount. Then I'm omitting everything where there's no date available, so get out with 30 data. And I'm using the POSIX-CT functionality from R to transform the date into a form which most of the functions in R can work with. So we have to convert the date format, the internal date format. And I'm using the ggplot library. As I told you, there's over 15,000 libraries. Now you've seen coplot, now you're seeing ggplot and scales. ggplot is doing the plotting. It's depending on, the name is GG for grammar of graphics. So we're building up a plot with a certain grammar, which is typically for ggplot2, which has nothing to do with grammar in R or in other visualizations. And 2 is the successor of the first one. So Hadley Wickham, the author of the thing, started over again and started over with a new name, ggplot2, instead of improving the older package. And scales is for helping me to have like the scales in this format. So 5 million would be that. The default in R, as is coming from a statistician and mathematician, oh, difficult word, from mathematics, they're using the scientific format. So this would be, instead of 5 million in this format, it would say 5E06. So 5 times 10 to the potential of 6, sorry. That's happening here. And then we have ggplot. I'm passing in the factory solo sales. That's the data frame I'm getting from Power BI. On the x-axis, I want to have the order date. On the y-axis, I want to have the sales amount. And then I'm using the third color, which is obviously green. You can also use names here. I'm increasing the font size to 18 to make it more easy for you to read the stuff on the screen. I'm introducing a continuous scale on the y-axis going from 0 to 5 million with this labeled comma, which the scales package is happening here. I don't need any legend. I add the labels here, like the sales amount here and the order date here. This is coming from this part. And then I added the trend line. So start smooth with the linear, the LM is the linear model, which is a simple linear regression line. And for example, we can set this on to true, then we get the confidence interval. So we get like a belt around the line showing us how sure it will be or how sure the model is. So it's more sure here than at the end, for example. That's the confidence interval, or we could also use the local regression algorithm. So this is like, this could be not a straight line, but this could be like a curved line. If this is better to your data, depends on your data and your model and what you think about your model. So straight line per se is not bad. It's easy to understand, but of course it's not that precise. If this is better, you have to find out. So how I'm doing time-wise. 20 minutes to go. So I will show you, we jump over to this thing here, and then I will open up for Q&A, I guess. So we have in the model, I'm not sure if you're aware of AdventureWorks, if you worked with AdventureWorks, but I was always curious. In AdventureWorks, we have this product table, and this product table has an English description of the product. And I'm working with AdventureWorks rather long now, and I was always curious, what could I do with this column? I mean, of course, I can count the words there, I can read it, but what kind of insights could I come up with from this English description thing? And one is, of course, in the visualization, we can use the word cloud, which is also a custom visualization, word cloud 2.0 I'm using here. And if we change this, we get a really nice word cloud showing us, depending on how often a word comes in a description, the bigger the word will be. Unfortunately, the text is in English, and in English, the most important or the most the most often words are, for example, de or e or for or and or with, which is not really helping me, because I'm more interested in terms like aluminium or riding or bike or frame. And this is like noise to me. So can I get can I remove those words, those stop words? And this is what I came up here. So I have 3 different solutions for that. One is the cognitive services. So in cognitive services, I use cognitive services to get me the key phrases from the description. So put the cognitive service up there. Now, it doesn't matter. And if I change this to a word cloud, we can see this is the so here we go. There's the word cloud. We have the very same text, but now I got rid of those unimportant stuff. And now I see that mountain or frame or road or aluminium, still aluminium is important, are the most important words there. So this is one way. The other way is that I use not only cognitive services, but also Azure Machine Learning Services. Again, extract the key phrases. This is, the first one is similar or they're very identical to cognitive services, because I used the built-in functionality in machine learning services, which is obviously very identical to what cognitive services also offers. And the third thing was that I used Azure Machine Learning Services, but came up with my own text, with my own text mining thing to get rid of the unimportant stuff. So this is slightly different from the other ones. But of course, the most important words like mountain, mountain, mountain are there, and they're well hidden in this thing. So how did I made up this? And now we're turning into something which could cost you something. Everything else I showed you, R, for example, is for free. Power BI Desktop is totally for free. If you're using those Azure services, of course, Microsoft cannot give you this. This is like computing resources and disk space and memory, not just for free. There are subscription models available for free if you want to test it out. I think you can test this out without any cost. But if you want to go into production, then you have to carefully think about that you pay exposing data to over the internet to a service out there, and B, every time you refresh your Power BI desktop file, the service is activated and all the data you're loading in are sent over to the service, and you're paying as you go. So for example, for cognitive services, I think for every 1,000 data rows you're sending over to cognitive services, it's about 80 cents. So it will not kill you if you try this out, even with a not for free subscription. But in the long run, you have to think about a better model, maybe building up a data warehouse and only sending the new data over to the service. So how did I build this? I'm going to Power Query. So Power Query helped me in building this. So for cognitive services, what we see here, I came up with the following things. So first thing is, I came up with two parameters. So the API key and the endpoint from cognitive services, I did not put directly into my code, but made a parameter. So in case I have to change the API key, because it always happens to me that I give away my file. So if you need this file to play around, I will gladly give it away, and so you can play around. But sometimes I forget about changing the API key, and then I'm giving away not only the demo file, but also my key to the cognitive services, and then you can use cognitive services on my cost, and then I have to change this. And it's much easier if it's just one space here, the API key and the endpoint. And then I used Power Query functions to like have a layer between my data and the functionality from cognitive services. So cognitive services has plenty of services. I only have functions for 3 of them, and this is only a part of the text-related cognitive services. There's, I don't know how many services out there. Really, really cool. So what I did show you was the keyphrases API, which is a functionality here, and there's also languages, sentiment, and I also translated the data. So sending over the English text and return the German text, as I'm situated in Austria, and so I can see, is this working or not? And in the end, this is the data set I did show you, product cognitive services, where I had the text with all the containing all the stop words. I sent over all the rows to cognitive services, and then it returned to me the key phrases. So this is what we see here. So cognitive services, I booked several of those functionalities, and you can see here there's the product key. Can you see this? I will zoom in here. So there's like the product key and the English product description. This is like the data from my data warehouse, from Adventure Data Works, Adventure Data Warehouse, AdventureWorks Data Warehouse. And key phrases, this is the result where I applied the key phrases function onto my English product name description here. And this is what it returned. So for most of the first things, it just returned the very same thing, but omitted like things like ML or HL and made everything lowercase. If we scroll down more, where there's more text, it should show that like here we get like the sport 1000 hammer, blah, blah, blah. It extracted like the key phrases. It's blue, it's a universal fit, it's a helmet, and so on and so forth. So how did I do this? I got there English product name description, and then I said add column, and then I invoke custom column. So I take this column, send it over, give it a new name, key phrase 2, and I use one of my functions, and I use the key phrases API function, which I will show you in a minute. And then there's the English product name and description. This is the name of the column I want to send over to the functionality, to the service, which then returns me the key phrase. So now we know that. How is the key phrase API built up? This is a function which I built in Power Query. Again, not really true. If you see the advanced editor, I did not build it, but Microsoft does a really, really good job in documenting stuff. So if you go to this link, this is also available in the slide deck, docs.microsoft.com, blah, 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 cognitive services, you will see this code, and you just copy and paste the code. I only did 2 changes to the code from the web service. It did work, but I wanted to parameterize. So instead of putting in so this is the name of the step in Power Query. This is the name of my Power Query parameter. So I didn't want to change it in the queries, but I have this parameter API key, and the same is true for the endpoint. I made a generic endpoint, and then I just added the parameter for the key phrases or for, what's the other one, languages and sentiment. That's the only changes I did here. And then we can use this. How do you get cognitive services? That's the last step. You go to your portal, portal.azure.com, and at the portal.azure.com, you can create resources, for example, cognitive services. And this is really easy because you just click on cognitive services, create the cognitive service. Did I just create it or just select it here? I think I go back here and I press plus, create resource, and I create a cognitive service. This is really simple. Cognitive services, here we go. And then I have to test in the name. It's explaining what this is about. As I told you, it's not only text, but it's also vision and audio, and really nice services available here. And then I give it a name. So this would be Power BI AI webcast. I use my subscription. The location should be, of course, close to where my data lives. So usually I think I use the North Europe thing because I'm hosted in North Europe pricing tier, and the resource group, if it's not existing already, you can use, you can create it from here. And yes, of course, we understand everything here. Create, and with a couple of seconds, less than a minute, we have a new cognitive service, which will then show you the API key and the URL you're using then here for the API key and endpoint, and then all your services are up and running. It's complete. This is really good. And then we get, like, I think if I go here and so get to resource, that's for sure the step. And then the newly created web services shows me the key and the endpoint. These two things, of course, you can write this down, but I will drop and kill this service afterwards. So how much time left? 10 minutes left. So I can also show you the other two. So the other one would be the Azure Machine Learning Services. So cognitive services is really cool because, as I just did show you, it's really easy to set up. Don't need any knowledge. You need an Azure subscription, which can be for free. And then you follow the steps like on the documentation or in this webcast to pass in the key and the endpoint. But on the other hand, it's not very flexible. So if you don't like how the key phrases are extracted or how the audio is detected or how the sentiment analysis is done, then you're limited here. This service is trained and improved by Microsoft, but you cannot influence it anyhow. If you need more flexibility, go for Azure Machine Learning Studio. Azure Machine Learning Studio offers you also to create a cloud service, a service in Azure, but you can create it on your own. And if you see that I've already have one extra key phrases, and we see how this looks like. We can also click in there. It will look the same. So if you're familiar with, for example, integration services, this looks very, very similar. So we have these items here, and they're connected, and this is how the data flows. So these extract key phrases, we are now in the experimenting modus. So I use the book reviews from Amazon, which is a data set available over the samples here. So I think there's the book review from Amazon. You just drag and drop this here. So you add it to your experiment. And then you add the next thing. So I added the metadata. So what did I do here? I only selected certain columns, only the product key and the English product name. Then I partitioned the thing. Not really. I think I just used this to split it up, to send one part or the same part first to the extract key phrase from text, which is another thing here, extract keyframes from text. And this, I believe, uses the same binaries like the cognitive services. So now we're having like more flexibility around, so we can clean up the data, which the Power Query or any other program sends over through the API. And then I use the existing data and add the new phrases. So we have returning 3 columns. And if you've done this, you just run this. And if you've run it, you can deploy this as a web service. This is what I already did. I do not want to start this here because it takes a minute or so. I don't want to wait. So we get this web service And again, it is a web service you can click, and from the web service you get again an URL and a key, which you then use in Power Query. So let's go back to Power Query. I have the HTML example here. So again, we have a web service API key, and we have a request URI, and that's what I used here. So I have again my product key and my English product name, and then I created, where is it? This was the R thing, was the other thing. I have three functionalities here. For HTML, it's a little bit more tricky because you have to convert your data you want to send over into JSON, then send it over to the service, and then get it back as a JSON and convert it back to a column. On Docs, there's a documentation how you can do this with an R script, for example, but this did not really work for me. So I asked my dear friend Gerhard Brückel, and he told me that he has a blog out there since many years explaining or having a script where you can exactly do this. So converting your thing, the Azure thing into the JSON and then send it over and back. So I didn't touch any of this code, and this is really, really working for me. So I'm using these functionalities, again, applying it to my data. So this key phrases, again, was done by add columns, invoke functions, and this time it was the call Azure ML service functionality. Call Azure ML, yeah, this one, yeah. And the third one was with R. So I used, I created an experiment, not using the built-in extract thing, but having, so this is the very same except this one, execute R script. So I have an R script here, which I can came up with, and there I have all the steps I believe that are important in this case. So I'm cleaning up the thing, I'm only use the stem words, I remove numbers, I strip white spaces, I remove certain stop words from a list I got somewhere, just built into this functionality, punctuation, and so on and so forth. And I have this there, and again, I can then run this, deploy it to the web service, and then use my very own R script and reuse it in many different cases, like in Power Query by calling the web service. So 5 minutes also left. So the question is, are there any questions? Shall we open up for Q&A, or I'll just go to my slides and show the last slides. Deepak, are there any questions? I cannot hear anybody, so I wrap up the thing here. So the first thing I did show you was the Q&A feature, question and answers. You're asking questions in natural English language, and then Power BI provides you with answers from the dataset and the data model. This covers several things, and here's the link if you want to read more about the Q&A feature. The second thing was the quick insights, where we asked the model, please explain me why is the sales amount in a certain point the highest? Do you find anything here? And again, there are several things the quick insights can discover, not only in trends, but also other things, and all the documentation is out in this link. The what if parameter was the thing where we built the example with the elasticity. So if we lower the prices at a certain elasticity, how will this impact our sales? Will the sales be more or less? Analytic line, we have seen on several things. One was the line chart to see the trend line, and we can also build the analytic line with DAX or R custom code if you want. Gives you more flexibility, but then you have to write and maintain code. Cognitive services was antivariant. That's the pre-trained machine learning models. Some data scientists at Microsoft train those models, so you can believe that they're really, really good, but maybe in certain circumstances, they do not fulfill what you would expect from them. So yeah, here you see again how to get the endpoints into the thing. If you want more flexibility, then Azure Machine Learning is your friend. This is using self-trained machine learning models. So you can, but you also have to then train the models and then convert them to a web service, which you can then use in the other things. And again, how to find the API key and so on and so forth. R integration, really, really cool. I did only show you how to integrate R in a visual, but you can also use it as a source or transformation within Power Query. Here are the links where you can learn from that. And yeah, I didn't have any time for web example, which is really, really cool. You can connect to a web page and then just type in samples, what you want to take from this web page, and then Power Query will find out how to get everything and fetch everything from the web page. And the similar thing is the column by example. If you want to create a new column in Power Query, so not a calculated column in DAX, but in Power Query, then you can just type in what you want to have from these columns, and Power Query tries to find out, which I think is also like artificial intelligence. I don't know how they implemented this, but this is a really, really cool feature. Check this out if you have time for that. Other than that, docs.microsoft.com is really, really good. Since 2 years or 3 years now, they changed everything, the look and feel there, so the translations are way better now. And if you find a bug, you can just file a pull request on Git and can make the documentation even better. Are there any questions? Deepak, I think we just went through in 60 minutes. So if you have further questions, feel free to contact me, reach out to me. I'm glad to hear about that. And I think we can also discuss everything on the blog post. You should have seen on LinkedIn or Twitter. And I think this video will also be put on YouTube. Please add comments there, and I will make sure that I can maintain and give you the answers to your questions. If there are no questions, I say thank you very much for attending this webcast, and see you soon, for example, next week. And in 3 weeks, I do another one about Power BI data model and Power BI DAX. See you then. Bye-bye.